So we have two different circuits here, right? We've got the circuit that involves R1, R2, and R3, and we have the circuit that involves all four resistors. So when the switch is open, just from a, well, I'll tell you what, let's just do this. The three resistors, the total resistance is just R1 plus R2 plus R3, right? So that's 6 ohms. And so the total current is 24/6, which is 4 amps. And at that point, since I total is 4 amps, that means that the current passing through resistor 1 is also 4 amps, because all three resistors are in series. And so the power dissipated by resistor 1 can be given by I squared R, which would be 16 watts. Now when the switch is closed, what happens to the power dissipated by the resistor R1? From a logical standpoint, when S is closed, the overall resistance of the circuit decreases, because you're giving current more choices. You're giving it a choice whether to go through R3 or R4, and therefore the overall resistance decreases, and so the overall current will increase, and so I would guess that P1 is going to increase. We can find that out, right? So let's go ahead and do that. We're going to need to solve this circuit with the switch closed anyway for part B. So when the switch is closed, R3 and R4 are in parallel, right? So I'm going to redraw this circuit as R1, R3, 4, and R2. Okay, now R3, 4 is 1/3 plus 1/4. So R3, 4 works out to be, I guess, 1.714 ohms, right? It's 12/7. And so in that case, our total is the sum of these three resistances, and that's 4.714 ohms, right? So you see how when the switch is open, the total resistance is 6 ohms. When the switch is closed, the total resistance has decreased, as we expected it would. And so in that case, the total current is 5.09 amps, and the power dissipated by resistor 1 is, I guess, 5.09 squared times 1, which is about 25 watts. And so the power increases. Okay, P1 increases. So we have justified this both logically and mathematically. Now for part B, it asks, when the switch is closed, what is the power dissipated by the resistor R3? Well, for the resistor of 3,4, we need to solve for that resistor first, right? We know that the current passing through that resistor is 5.09 amps, and we know that resistance is 1.714 ohms, and therefore the voltage drop across there is 8.73 volts. Okay, well, if the voltage drop across R34 is 8.73 volts, that means the voltage drop there and the voltage drop there is 8.73 volts. Okay, so the voltage drop across resistor 3 is 8.73 volts. And the power dissipated by resistor 3, well, we can use delta V3 squared divided by R, and that gives us 25 watts.